Good morning, guys. Welcome back to algebra. So as you can see, we're going to try something a little bit different today. Depending on what our topic is and how I'm feeling about the technology, I'm going to mix it up. So sometimes I'll do short little videos like this, and then sometimes I'll do like what I did before when it's a program and you can't necessarily see my face, but you see what I'm writing. So today's topic is solving inequalities, and it's really just a review for us. So not yesterday, but last class, you were working on solving equations. There's only one big difference between solving inequalities and solving equations. You use the exact same process, meaning you use all those inverse operations, but the big difference is in an inequality, there's more than one solution. So for an equation, there's only one number that makes the sentence true, that balances the equation. For an inequality, there are usually an infinite number of numbers that will solve it. So let's start with a quick review of our signs. All right, at the top, we have these two signs. They are related. So the top one says less than. And the bottom one, you'll notice, has the same symbol, and then it has that extra little line. Remember, that extra little line is half of an equal sign. So this one means less than or equal to. On the bottom, we also have two signs. The top one is greater than, and the bottom one is greater than or equal to. Now the other thing we had to remember about these signs, if it has half of the equal sign, and we would pronounce it as either less than or equal to, or greater than or equal to, that changed how we reported it on our number line. If it can be equal to that number, meaning if I solve this and I find out that it could be equal to whatever single number I get, when I graph it on my number line, I'm going to color in the dot because that indicates that number is a solution. If it cannot be equal to that, if it must be less than or must be greater than, I leave that dot or that circle open to indicate it can't be this number. It can only be every number either in front of it or behind it. All right, so let's solve this inequality. So we're going to start by drawing our line down the inequality sign, just like what we would do if it were an equation, and we're going to use our inverse operations. So we have plus 5. We're going to subtract 5 from both sides of the inequality sign. That turns this into 0. I bring down what I have left. I bring down my inequality sign. 13 minus 5 gives me 8. And my last step is to divide by 2, and I end up with x is less than 8. So this means any number that is less than 8 will make this a true statement. So when 8 divided by 2 is 4. Hopefully you caught that. There we go. This means that any number that's less than 4 makes this a true statement. So when I go to look at my number line, I find where 4 is. I'm going to put an open circle, meaning 4 can't be a solution, but any number less than 4 can. So I shade in every number that's less than 4. And I draw a little arrow to indicate that it could go on forever in that direction. All right, there was only one other special rule with inequalities. So I'm going to take this board, and we're only going to change one little thing about what we just solved. We had 2x, so we're going to make it negative 2x plus 5 is less than 13. All right, we're going to follow our same steps. We're still going to subtract 5 from both sides of the inequality sign. So now I have negative 2x is less than 8, and I'm going to divide, but this time I'm dividing by negative 2. 8 divided by negative 2 gives me negative 4. And here's the one extra rule. if you divide by a negative or multiply by a negative, you must change the direction of the inequality sign. So it will no longer be less than, because I divided by -2, it's now going to be greater than. So when I go to graph it on a number line like this, my sign is greater than, so that means it can't be -4, so I put an open circle on -4, and I shade in the direction where numbers are greater than -4. They're greater in that direction. And if you're wondering why, remember when we did this little experiment? If we have something like 2 is less than 4, that's true. But if I multiply both sides by -1, I now have -2 is less than -4. But that's not true, because if I look at a number line, -2 would be right here and closer to 0. Therefore, it's actually greater than -4. And that's why when we multiply or divide by a negative sign, we have to change the direction of the inequality. That was the only big difference between solving an inequality and solving an equation. Our answer can usually be any of an infinite number of numbers, and if we divide or multiply by a negative in our final step, we flip the inequality sign. All right, guys, we've got a quizzes up. It looks very similar to this. Good luck, and show me what you know.